Okay, so this video is going to be focusing on partial quotients with 2-digit dividends and 1-digit divisors. There's going to be 2 problems that you can follow along with. You can pause the video at any time, and I would do the problem with me as I'm modeling it. I'm going to start with a problem 68 divided by 3. Remember, our dividend goes on the inside, divisor goes on the outside, and our quotient, our answer to our problem, is going to go at the top. This problem can also be written as 68 divided by 3 as a fraction, or 68 divided by 3 this way. All right, so we're going to start with listing our multiples of our divisor. We're going to only start by listing the first 5 multiples. And I know 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. But remember, when I'm doing this process, I want to get as close to 68 as I can, so that way I have less subtraction, less repeated subtraction to do throughout this process. So we all know our multiples of 10, so I'm going to start here with 10. 10 times 3 is 30. All right, so I need to figure out what can I multiply by 3 using my chart to help me. What can I multiply by 3 where the product is going to get me as close to 68 as I can? Well, let's look at my chart here. Noticing that these are my factors, this is my product, okay? Well, I see that 3 times 10 is going to give me 30. And 30, according to this, is as close to 68 as I can get by referring to this chart, okay? So I'm going to make a section here to put my partial quotients, and I know that 3 times 10 is 30. So I'm going to subtract 30, which is the product of 3 times 10. So 8 minus 0 is 8, 6 minus 3 is 3, okay? All right, so I need to think about what can I multiply by 3 where my product is going to get me as close to 38 as I can. Well, I can do 3 times 5 to get me 15 and just keep subtracting 15. But if I look here again, I could do 3 times 10 again to get me 30, and now I'm going to subtract by 30 one more time. Now I know that my subtraction, this process is complete when the difference, the number that I have gotten after I subtracted, it needs to be smaller than my divisor. So this 8 is obviously greater than my divisor still. So now I need to figure out what can I multiply by 3 where the product will be close to 8. Well, let's look at my chart here. I see that 3 times 2 is 6, so I can subtract 6. And I already said 3 times 2 is 6. So I need to put my 2 here as a part of my partial quotient, and 8 minus 6 is 2. All right, so I know I'm done here with this part because 2 is less than my divisor, which is 3. All right, so how do I get my quotient here? I have all of these partial quotients on the side, 10, 10, and 2. So I'm going to add 10 plus 10 plus 2, 10, 20, 21, 22. So that's going to be a part of my quotient. Now what do I do with this 2 here? If you can remember what we did with the tiles in our lesson on Tuesday, where I had 1 or 2 tiles left over, those were my remainder. Those we called those leftovers. That's what this is right here. This is our leftovers. We call this our remainder. So to represent my remainder, I'm going to do R2. So my quotient is 22, remainder 2. All right, well, how do I check this? So to check, I need to use inverse operations. So I'm going to multiply to check, because multiplication is the opposite of division. So I'm going to take my quotient, which is 22, and I'm going to multiply it by my divisor, which is 3. Okay? Now most of us are using area model to multiply. If you're using algorithm to multiply, that's fine too. 20 plus 2 times 3. 20 times 3 equals 60. 2 times 3 equals 6. 60 plus 6 equals 66. Now, what am I looking for here? Well, I'm looking for my product to be the same number as my dividend. Well, it's not. I've got 66 here, and I've got 68 here. So where's that extra 2 coming from? Oh, look it. There's my remainder right there. My remainder is 2. So I'm going to add 2 to 66. I always want to add in my remainder. And now I know my answer is right because this matches my dividend. So the quotient of 68 divided by 3 is 22, remainder 2. Okay, at this time you can go ahead and pause the video if you'd like, or if you would like to watch another example of partial quotients using 2-digit dividend and 1-digit divisor, you can stay tuned for this one. I am going to do now 89 divided by 6. Again, let me show you another way that this is going to be represented. And we want to really understand this because you're going to be seeing different ways that division problems are going to be shown. They might be shown as a fraction like this, where your dividend is a part of your numerator, your divisor is your denominator. It might be like this, or the most traditional that you're probably familiar with, like this, okay? But in order to do the partial quotient, we want to stick with this representation right here. So we always want to start with our multiples of our divisor. We're going to list our multiples of 6. And if you don't know your multiples of 6, you have your multiplication chart. That's why we want to focus on making that multiplication chart again and again, because these multiples are so important. If you make one mistake with these multiples, your whole problem is going to be off. So we want to